Welcome, everyone. Thank you for joining us for today's group interview with the eVTOL Writers Group. This is Jim Sherman, and I'm the Director of Strategic Development at the Vertical Flight Society. For today's program, we have Gary Gysin, the CEO of Wisk. So it should be a very excellent presentation and interview. For a little bit of housekeeping before we get started, in your webinar control panel, you should see a little box that says questions. So if you have questions for Gary throughout the presentation, just go ahead and type them into that questions box, and our moderator will scroll through those at the end of the presentation, and hopefully we can get your questions answered today. So with that, I will go ahead and kick us off. Our moderator today is Charles Alcock. Charles has been an aviation journalist since 1986, having served most of his career with Aviation International News in Europe and in the US. He was formerly editor-in-chief of this international media group and is now the senior editor in charge of creating AIN's new futureflight.aero platform to cover new aviation technology and business models. He has a degree in politics and modern history from Manchester University. And so with that, I turn it over to you, Charles.
Thank you, Jim. Thank you very much indeed. And hello, everybody. Thank you for joining us for this Vertical Flight Society Writers Group discussion. I know that my colleagues and I value the chance to learn more about key players in this fascinating sector of aviation. And as Jim said, today we're going to be engaging with Gary Gysin, Chief Executive Officer of eVTOL aircraft pioneer Wisk. Now, Gary brings more than 30 years of experience delivering market leadership and rapid growth in the autonomous vehicle sector, as well as in energy, Internet of Things, and enterprise high technology sectors. Before joining Wisk, Gary was the president and CEO of a company called Liquid Robotics that is part of the Boeing Group, and they're engaged in autonomous ocean robotics. And basically what they've done is find new ways for the world to access, collect, and monitor ocean data. But now he's back up in the clouds with the rest of us. Also on the call today is Jim Teague, who is Wisk's Chief Technical Officer, and he may be able to supplement some of the knowledge that Gary's going to share with us. Jim's a Collier Trophy and ex-prize winning engineer. I'll stop his blushes there. He's worked previously, before joining Wisk, with Kitty Hawk, and prior to that, he was chief aerodynamicist for Scaled Composites. He worked, for example, on the Spaceship One project, as well as the Firebird UAV. And prior to that, he spent time at Boeing, where he worked as part of the stability and control group for the 777 airliner. So just by way of a little bit of background, it was about a year ago that the Cora aircraft was one of 3 eVTOL projects being advanced by startup company Kitty Hawk. And at the same time, aerospace giant Boeing was working on its own plans for the sector. Well, the two companies joined forces to create Wisk last December. And this was in order to focus on getting the Cora to market. Now, some would say that the industry is about to see what can be achieved when tech entrepreneurship meets big corporate aerospace. But don't take my word for that. Gary, would you please update us on how your plans are progressing and what we can expect to see from Wisk in what remains of this crazy dystopian year? Over to you, Gary.
Yeah, okay, Charles, thank you very much. Sorry, I've got to readjust my screen here. There we go.
Perfect.
Okay. All right, good deal. Well, I appreciate it. I've spoken to several of you previously, and I would just add to Jim's resume a bit. He's a very modest individual, but he's the we call him the father of Cora, as he was the primary inventor of the aircraft that we have now, which is just a fantastic innovation. I'm going to take you through just quick update, quick highlight, and then really what this is designed to do is whatever questions you might have, we're prepared to engage for as long as you'd like to go and either talk about the industry, talk specifically about what we were doing, and take it in any direction actually that you want to go. So I'm excited for this format. I think it's great. It's a great way to update, and then you know, any insights and things and perspectives and opinions you want to fire back our way will be great when we get to Q&A. Chris, can you go to the next?
Yep.
All right, so there's obviously why we do it. And there's a prize at the end if anyone can figure out which city this is. But you know, traffic jams are all over the globe. On average, in congested cities, people spend upwards of 9 days a year just sitting in their car commuting. And so, you know, you look at that as wasted time. Trying to solve this problem. I mean, this is what urban air mobility is all about, and trying to figure out how we can make this more productive and get people where they need to be. And just another stat, you know, by 2030, it's expected that 60% of the people live in large cities. So this problem won't go away. Next slide, please. So less time getting there means more time being there. That's, you know, that's really our vision for this. And it could be quality of life. It could be getting there faster to your family, getting to a vacation, getting to a work meeting, or an emergency, if you will. And so, you know, we think of this in the sense that, you know, probably a lot of us on this call fly more than most folks commercially. But if you take, you know, 5 to 10 commercial flights a year, you could imagine once this is deployed in cities, you could be doing this twice a day. So taking a flight twice a day. So that's how we think about, you know, developing this. And obviously the benefit, we've got to solve the whole multimodal part of it. So the flight is part of it, but obviously you have the endpoints where you've got to get people to where they want to go quicker. And so we can talk about that a bit more later. Next slide. So our mission, deliver safe everyday flight for everyone. So a couple of things. And this is actually Jim, and this is one of his children. And so the idea is, you know, if Jim and the rest of the team is comfortable, you know, putting our kids in something like this, then we will have achieved something. Also, we don't, you know, several of you I've spoken with, and we don't give dates. There are a lot of other people that are out there saying, we're going to fly to New York City in 2023 or 2025, or we're doing this, that, and the other thing. We're working with regulators. I'll go through it in both New Zealand and obviously the FAA in the US. And when we're certified and we're safe, we'll fly. And so maybe it's frustrating, but for us, we're not going to commit to a specific date to fly anywhere. We're far down the path. We'll go through, you know, the things that we're doing, but you know, it's up to the regulators. And when we're certified, then we fly. And then the other part, you know, we understand this market will probably start with the premium flyers. You know, those will be the ones that have the most urgent need. And, you know, if you think of it like an Uber Black type of customer, that's probably the way it starts. But our goal, and why we're doing what we're doing, why we're doing self-flying, why we're doing electric, et cetera, is get the cost down. Get maintenance costs way down, get the cost of the airplane down, so that we can provide flight for everybody. So that this becomes, you know, a standard commuter thing, and is not just you know, for the premium customers, if you will. Next slide, please. Okay, so we are actually 1 year. We just crossed on July 1st of being Whisk. Now, Charles, you are correct. We didn't announce Whisk until December of 2019, but in fact, we were in stealth mode for about 6 months. We had formed the joint venture. I had joined. We'd started to build the team back July 1st of 2019. But this idea started 10 years ago. And if you go to the next slide, I'll kind of walk you through the progression. So in 2010, Larry Page formed a company called Z, and it was about, you know, at that time, flying cars. And you can imagine back in those days, that would be, you know, out there, an out there idea, but, you know, certainly Larry, you know, of Google fame has, you know, established credibility in terms of an innovator, you know, worldwide. And so he started this group, and it was really to pioneer some different self-flying ideas and to see what took hold. It merged with another company called Kitty Hawk in 2016. So I'm going through this because some of the names can get confusing when when people hear about Whisk and is it Kitty Hawk? Is it Boeing? What is it? So Kitty Hawk, as Charles had mentioned, had 3 different projects. Cora was one of the projects. So the aircraft itself is called Cora. They have a second project called Flyer, which they just recently canceled, and a third project called Heaviside. So you might be familiar with those concepts. What happened was you could think of Kitty Hawk and Z as the combined entity, still funded by Larry Page, and really an incubator of different ideas. And one of the things they saw with Cora was that it had incredible commercial potential. Not all the things they do out of Kitty Hawk have commercial potential, but that this one did. And what they needed to do is go find an aerospace partner. And so they went through a vetting process and ultimately ended up selecting Boeing, and Boeing in turn selecting Kitty Hawk to partner with. The whole team was spun out of Kitty Hawk. It already was a separate team and a separate building and all that, so that was pretty straightforward. So that was spun out. I came in at the time of the formation, as did some other folks, and we started building the team from there. So we've been Whisk. As Ed mentioned, we didn't announce it until December of 19, but it was actually formed in July 1st of 2019. So hopefully that helps. There's one other name that you might hear that, again, try to clarify all the naming. In New Zealand, we have a subsidiary. I'll talk more about New Zealand. It is basically, they are the operator, and they will be for the service that we're going to run in New Zealand. They were called Zephyr Airworks. It's now Whisk New Zealand. So a whole bunch of names out there. I wanted to try to provide some clarity. Everything is Whisk now. Everything is separate. We literally have nothing to do with Kitty Hawk and their projects. They do have a couple board members, but other than that, it's a separate entity. So next slide, please. So where are we today? So 300 employees, most are in engineering, manufacturing, and flight test. And so that's the bulk. I don't have the exact percentages, but if I had to guess right now, I'd say 85% of the team is in those 3 areas. We've got locations in the Bay Area. In Mountain View is where our headquarters is. Palo Alto, we have some manufacturing. We also have an operation in New Zealand. Again, I'm going to talk more about that because that's a really important development path. And then we have a software development team that's in Atlanta. So, we're starting to spread around. Roughly 120 patents, both US patents and international patents. This is something that we think is pretty unique in this marketplace. As I'm sure you all know and you cover, there are lots of people that are announcing eVTOL things. A lot of them are concepts, CGI videos, that sort of thing. We've got over 1,300 test flights on our full-scale aircraft, and those are 7 full-scale aircraft. And knock on wood, without an incident. So it's gone quite well. We test both in Hollister, California, which is about an hour from our headquarters in Mountain View, and then also in New Zealand. And so in any particular day, we could be flying in both locations, depending on weather. Maybe one location doesn't fly and the other does. It also obviously depends on what we're actually trying to test. Boeing came in, as I mentioned earlier, as an investor, and Kitty Hawk as an investor in this joint venture. And they come in also as a partner for us to leverage their engineering if we want to, their certification experience. They're certainly helping on the policy and regulatory front. So it's been a great partner addition to us. So Boeing is not just an investor, but we also have a master services agreement set up with them, and we can pick help that we need in different areas and have them augment our team. Next, please. Okay, so our flight journey. So this is interesting, and so the evolution of how we actually got to the Cora aircraft. So it started back in 2014. This was an electric eVTOL, or sorry, it was electric VTOL aircraft, about 600 pounds, so not the full weight of what we have now, but a full-scale aircraft. And so this was the first vertical and then transition to fixed-wing flight that occurred back in 2014. So we consider that, the first proof of concept. In 2015, what the company did is decided to take some of those concepts, but really test more of the fixed wing characteristics of the aircraft and really get the wing dynamics nailed, if you will. And so that aircraft in 2015 took off on a runway, like a normal aircraft. And again, we're testing more of the wing characteristics to see if we could fine tune that. That was a manned aircraft. Then in 2017, also a manned aircraft, but this was an eVTOL, and so first full transition with getting closer and closer to the architecture that we currently have in the Cora aircraft. Then in 2017, that's the first time that it was a self-flying eVTOL, and so we consider that our fourth generation. And so obviously a momentous occasion for us to be able to do self-flying, do eVTOL, do full transitions and all of that. And then the Cora, now that we call it Cora, starting in 2018, really that has things that we needed to add to the 2017 generation aircraft for certification in New Zealand. And so we had to, like DAL software as an example, upgraded aviation quality sensors, things of that nature. And so that's the current Cora aircraft. So the 2017 Gen 4 was pretty darn close to the architecture, but in 2018 we had to upgrade, with things that would allow us to get certified. So next. All right, so what Cora is today. So, as I mentioned, it is self-flying, it's all electric, it's 2-passenger. We certainly think that's a sweet spot for demand at this point. There's 12 lift fans, and you can probably see them fairly well on the graphic. So they're independent lift fans, and then there's one pusher prop in the back. It all has a consistent architecture. We leverage a lot of the engine technology for the lift fans and also the pusher prop. Lift fans obviously allow you to take off vertically and land vertically, and then the pusher prop, once we go into transition, we fly like a fixed wing aircraft. Transition time is roughly 30 seconds from liftoff to fixed wing flight. Well, our sweet spot is flying 1,500 to 5,000. In terms of Cora, we don't have any single point of failure. So we have, redundant lift fans. A lift fan fails, we're still fine. Redundant battery technology, redundant flight control units, and things of that nature. And so the idea is, obviously, as a self-flying plane and redundant comms. And so, if anything fails, we want to make sure that we've got secondary and tertiary backups to continue flight. Next slide, please. All right, so we're going to show you a flight test. This was done out of our Hollister facility. A little choppy on the streaming, but you get an idea of how the aircraft flies. The 12 lift fans on the wing. Range is about, right now, 25 miles with reserves. That's what we're expecting on this current aircraft. We will be increasing that. Sorry that it's a little choppy on the video, but on our website are plenty of flight videos. So, and again, that was from our Hollister, California Flight Test Center. So let me talk about New Zealand. We decided to start flying in New Zealand. They're very progressive. Sustainability and autonomous is a big factor for the country. Even though they're small, there was only 5 million people in New Zealand, they wanted to be a leader in the market and kind of set a global standard, if you will. One of the benefits that we are doing also is, in addition to, we formed a partnership with the New Zealand government. We've signed MOUs for aerospace integration and all the testing and the flights that we're going to end up doing, which is on the South Island of New Zealand for any of you that may have been there. We also have a partnership with Air New Zealand, and the idea there is we as Whisk are going to be the OEM. So think of the California operation as the OEM, and the New Zealand entity as the operator. So we're going to be OEM and operator. But the front end side of it, the getting customers, scheduling customers, doing logistics and all that sort of thing, we'll partner with people to do that front end part of it. We don't intend to build an app like an Uber application or that sort of thing. We'll partner with somebody else that will do that. And so we do have the partnership with Air New Zealand, which is pretty exciting. In addition, we are inviting other regulators to observe what we're doing there. And so, they can come in and observe. The New Zealand CAA is willing to share data with these other regulatory agencies. And basically what we're trying to do is one, learn from it, for what we need to do for the type certified aircraft in the US, but two, also just establish safety proof points and fly customers, fly people in our aircraft, get that feedback, understand, the social aspects of it, understand acceptance of it, the noise/annoyance factor, ride quality, all the things that we want to learn from actually doing this trial. So that will be first before we fly in the US in an urban city. And we can talk more about this later. Next slide, Chris. So why self-flying? Most of the people in the space are doing optionally piloted, as I'm sure you know. So we think, if you think of, we've combined an incredibly innovative team with an aerospace giant to build a commercial thing. If we think about the types of innovation that SpaceX did, with their efforts and reusable rocket launchers, I mean, our view of this is self-flying is the real game. There is a pilot shortage, that is a fact, obviously not right now based on where we are, but once we get back to normal modes of operation, it's easier to maintain if it's self-flying. We think it'll be, less errors potentially, more safe. And so we're fine with, somebody else that might be first with an optionally piloted solution. In fact, we would celebrate them and hope they do well. I actually don't worry about the competition. There's not that many that are credible at the moment, and I would really like to see all of them succeed because I think it's good for the market. Also, if you think about the globe and how many routes there are and types of customers and all that, there's going to be plenty of room. If you think of 4 or 5 people might survive this, the globe's a big place, and so there are going to be lots of routes. And so I really don't worry about somebody else being first. So we're driving straight to self-flying and building all the autonomy in the aircraft that we can. Now, we'll start with the pilot on the ground, and the pilot will be in a ground control station. They're not actively piloting the aircraft. It is self-flying, but they're monitoring it in case they need to intervene. And so, again, we can talk more about that later if there's interest. Next slide. All right, so what are we doing in the coming year? We are in the short strokes in New Zealand with the CAA. We're finalizing all the details on the trial, our certification. It is, think of it like what the FAA would go through with airworthiness on our aircraft, certifying our operation, certifying our manufacturing and production facilities. So we're going through all that. We think it's a big value add that we're doing this. Again, perhaps in comparison to some of the other folks that are building their prototypes and trying to go straight to flight in the US, we're having to grow up early, if you will, to be able to get certified. And so even though New Zealand has a different certification process than the US, it's very rigorous. It's causing us to improve our internal business operations process, best practices, all the certification documentation that we need to actually get certified. So it'll be a step on the way of doing this with the FAA. So we think, not only from a regulatory perspective, as I mentioned before, the customer learning, just the whole ecosystem and how we tie all this together and really learning from what we're doing in New Zealand. Next, please. All right, so what we think are shared challenges and opportunities in this marketplace, and it'd be great to have a conversation with this. Aircraft approval, obviously getting a type cert for any of the aircraft that are built in the urban air mobility space will be critically important. Aerospace integration is one that I worry about more than I worry about us building aircraft. I know we're going to build a fantastic aircraft and that we'll get a type cert for that. But if you think about, we're a piece of the puzzle. You have to have detect and avoid, and that's still a pretty nascent market. Is it ground radar? Is it optical sensors in the aircraft? Is it a small radar in the aircraft? Is it both? Those are the kind of things that we're working through with partners. We're not going to build that part of the solution. We're partnering with people that are. There are big companies, small companies that are playing in that area, but I would say that's one that has to increase its pace of innovation. And then aerospace integration. So if we're at 1,500 to 5,000 AGL, how does it integrate with air traffic control? Who are the operators that are going to manage that particular space? You have companies like AirMap and SkyGrid and other people that are, saying they're going to play in that space. But obviously, it all has to come together. New infrastructure is here. To be honest, we can start with existing infrastructure. Obviously, we would add electric charging stations, but if you think of GA airports, international airports, helipads, et cetera, there's plenty of infrastructure that actually exists. And there are concepts of obviously building, new vertiports and that sort of thing, which, we can get to, but we think to start, we can actually start with infrastructure that already exists. Public acceptance, huge. Helicopters have challenge because of the noise and expense, and getting through that. And then the last thing is, what I talked about earlier in terms of the multimodal experience. We're the mid part of the equation, if you will. How does somebody get to where they're flying with us, and how do they get to their destination after they land? And so we think all these things are critically important for this whole segment to be successful. So I think that is it, and we can probably open it up for Q&A.
Okay, Jim, I can take it from here if you like. So we do have some questions. We've got some excellent questions. In fact, they've been coming in fast and furious. Gary, if I may, the first question is essentially asking, who are you working with as a company? Who are you partnering with? And the core question is, what will be the model for suppliers who want to be considered for this program, assuming there is still opportunity for that? What sort of support, what sort of hardware are you looking for? And could you perhaps provide more detail with who you're partnering with already? You mentioned, developing access to airspace, for example.
Right. So there is, we haven't announced any partnerships yet. We will be in the latter half of this year. And so there are a ton of companies in the DAA space, a ton of companies in the aerospace integration space. We've got suppliers, of course, for the aircraft. We have partners that we use for some software development and things like that. So I'll probably have to be vague because we haven't announced any of these partnerships yet. I think we have close to 200 vendors that we're working with. Some are components, obviously, that go in the aircraft. Others are more full-fledged partners, like DAA partners, like aerospace integration partners. I think in particular in DAA and aerospace integration, it's still such a nascent market. We're still evaluating all the vendors, and so we have a partner evaluation process, if you will, that we take everybody through to see how they fit. So probably not a great answer. People wanted some more detail on that, but we've got lots of partners, but we actually haven't announced any of them yet.
That's okay.
Jim, anything you want to
add there?
No, I think that pretty well covers it. I mean, so we have a lot of technologies ourselves, but we're looking for some partners in some key areas to help scale, and also to enable us to operate in airspace. So, but key areas are things like detect and avoid, data links, ground control stations, airspace integration providers, and those are the areas that we're focusing on right now.
Yeah, and just to mention on that, for the Cora aircraft and the one that's flying in New Zealand, that was there are subcomponent partners that are part of that effort, but most of that is vertically integrated. And so as we are now on the type certified aircraft, there's opportunity for other people to be actually part of the core equation, if you will.
Thank you. And Gary, a couple of people have just piped in asking what's Boeing's role in this. Obviously, they're a key shareholder, but you've got that extraordinary reservoir of engineering expertise there. Are they directly involved at all?
Yeah, they are actually. So we, you know, as I mentioned earlier, we have a master services agreement with Boeing. We've got engineering people deployed, certification folks, policy people. They are building some interesting things that can be leveraged by us. And so it is much more than just an investor partner. The idea of Boeing coming in was obviously to do this, it takes a tremendous amount of capital. And, you know, when I mentioned before that, you know, maybe 4 or 5 people survive this, most would estimate it's $1.5 billion for the R&D part of this journey to get to a type certified aircraft. So $1.5 billion in funding. So that's not a lot of people that are going to make that journey. Boeing is certainly one of those that well, they understand obviously, you know, the aviation marketplace. But they've been tremendous. The other thing I'd add is safety. You know, that we're doing safety reviews with them all the time, and that's been quite helpful. Jim, anything to add?
Yeah, no, I mean it's you know, we're, you know, this sort of project requires a lot of resources, and especially having an established partner who understands the certification process and the system safety process and the aviation processes that, you know, have been so successful in the past is super helpful. And on the other, you know, on the scalability, having a, you know, a partner who can build you know, an airplane in a day, a large complicated airplane in a day is really fantastic.
Yep.
Good point. Now, a colleague who has just posed a question is obviously in the same situation as most of us, under house arrest for the past 3 months or so. Yeah. And he's asking, do you think the potential market size for urban air mobility could end up being smaller than previously projected? Because, you know, many people are just going to choose not to commute so much, if at all, as a result of COVID-19. And for those who do, maybe there's going to be less congestion on the road. So I guess what they're asking is, you know, does COVID-19 change the sort of market projections for urban air mobility?
Yeah, I mean, you know, and this becomes opinion. I mean, my personal opinion is that there'll be some people that might move to remote states and permanently work from home. But there's, you know, having done this now for, let's see, where are we? Are we going on 4 months, Jim? You know, I'm going out of my skin because it's just social interaction and being with teams and you know, how we interact and collaborate, you know, is tougher to do it in this video environment. So, I mean, I think certainly, you know, we're taking a hit in 20 and 21, but by the time we're flying in the US, I can't imagine that congested cities are no longer congested cities. And so maybe they're on the fringes, incrementally less congested, but I can't imagine that the problem has gone away. You know, people like to be with people. And so, and certainly in the large cities. So I don't know, you know, it's opinion. We're not worried about it. We think certainly these are tough and unprecedented times, but you know, we'll get through it, and then, you know, life will quote get back to normal.
Absolutely. I've got a couple of technical questions now. First of all, do the lift fans that you have on the Cora result in a lot of aerodynamic drag during conventional flight? And perhaps related, why are your rotor widths so narrow?
Jim, go ahead and take that.
So with respect to drag, maybe it wasn't obvious in the video that we showed, but if you look at our videos on our website, you can see it a bit more clearly. When we're flying like an airplane, the rotor blades, we say STOL, meaning they stop moving, and the blades are aligned with the booms, so they're aligned with the local flow. And our rotor designs are designed to have a low drag in that STOL configuration, so they're well aligned with the local flow. So the drag delta is it's something, but it's on the order of the same drag as the landing gear, for example. So we still have a good L over D, similar to what you'd find for like a Cessna. So the drag difference isn't as much as you might think. With respect to the rotor chord, so that's actually it's a bit large. The idea is you want to have enough lift from the rotors at the speed you want to spin them at to support the weight of the vehicle. And so, as most of the people on the call probably know, lower tip speeds means a quieter rotor system. Larger chords mean lower tip speeds and less noise. So it's a compromise between having low enough tip speeds, which drive chord, and noise. Unfortunately, as you lower the tip speeds, you also have to spin the rotor slower, which means more motor torque, which means more motor weight. So our rotor system is a compromise between higher tip speeds, which gives you lower weight, and lower tip speeds, which gives you lower noise. And that's what drives the chord.
Yeah, I would say from the video, I was watching it as well, and it looked like the lift fans were engaged as we were in fixed wing flight, which is actually not true. So, you know, as Jim said, when we transition, the lift fans will lock, you know, as he said, in line with the boom. So anyway, they're not spinning when we're in forward flight.
Fair enough. While we're on the subject of the rotors, somebody is saying, how do you ensure your users, meaning the passengers, can get safely in and out of the aircraft without the rotors being covered?
Jim, go ahead.
Sure. Yeah, so we have a number of safety systems that ensure that that's the case. First of all, nominally, when you get in and out of the airplane, you do so with the assistance of a passenger handler who will, at least in our operations in New Zealand, open and close the canopy for you. We also have software that knows when the airplane's on the ground and will inhibit the fans from moving while you're on the ground. In addition, while you're in the air, the canopy handle, you know, is not easily accessible. Or you can get to it in an emergency, but it's designed to be a two-step process to make sure that the passengers can't get out while the aircraft's in the air. While we're on the ground, we can remotely open up contactors through a safe and reliable and robust means to remove high voltage from the airplane so the fans are inhibited from spinning. So we have a number of mitigations, and on top of that, there are things like beacons and lights that indicate the aircraft is in either an operating or potentially operable state. If that made sense.
Yeah, Jim, I just want to emphasize one point. So when we're on the ground and passengers are loading, the fans aren't spinning. And so we don't have to spool up like a helicopter would and kick the fans off for, you know, 5-10 minutes before we take off. So it's quick to engage the lift fans to actually lifting off.
Thank you. Gary, somebody's picking up on a particular technical point here. You mentioned that the projected range for the Cora is 25 miles with reserves. By that, do you mean a sort of typical 20 minutes of reserves or something less than that?
Something less than that. So, so the 25 miles is what we've got today, or the target for what we're doing in the US is 40 to 60 miles. And not, you know, we could design technology to go further than that, but we actually think the sweet spot for the type of problem we're solving is in that range. And so we could have a 100-mile aircraft or 150-mile aircraft, but we think the sweet spot for urban air mobility is actually in that 40 to 60 range. So that is where we'll be going. Reserve-wise, you know, this is something, since it's not fuel, since we don't have to land at an alternative airport, you know, we can vertically land just about anywhere. That's something we'll be working with the regulators to determine how much reserve we actually need. Right now, our assumption is about 10 minutes of reserve. But again, we can land in a field, we can land just about anywhere.
Good point. And talking of regulators, somebody's trying to just clarify under what basis you'll be certified, FAR 23, 27 maybe, or a combination of either of those?
Yeah, it looks like it's 23 Amendment 64 is the path that we'll be going down, as well as several other of the eVTOL projects.
Mm-hmm. Okay, fair enough. And next question, what does the ground control station that you mentioned consist of? What controls will be available to the pilot when you get to that point?
Yeah, Jim, you want to take that?
Sure. So what we have right now is an external ground control station that allows us to do flight test efforts. So you can collect data, monitor the flight. There's a nice thing about a flying computer is it's naturally collecting lots and lots of data all the time. But for the operations, it'll be a much reduced ground control station staff, where we'll have an operator who, as Gary was saying earlier, is monitoring the flight. But nominally, the aircraft is executing the flight autonomously without operator intervention, other than hitting the fly button. As time goes on for our operations inside the US, we'll have more of a many-to-one model, where we'll have multiple aircraft being controlled by a single, being monitored, I should say, by a single ground control station. That, of course, has its own challenges, which is why a lot of our efforts right now are focused on aerospace integration activities.
Thanks, Jim. Gary, somebody's asking whether you are engaged already with the US Air Force's Agility Prime program, or whether you have any intentions to be involved in that.
Yeah, so it's a good question, and this is where the Boeing partnership comes into good play. Obviously, they've got a very large defense organization, and so part of the partnership allows for us to be an OEM in that case, build aircraft, and they can pursue different markets, military, cargo, emergency services, those sorts of things. So it's an open-ended playbook, if you will. So probably not best for me to comment on Boeing's engagement with the US Air Force, but you can imagine they have pretty extensive relationships there.
Yes, absolutely. Somebody is asking, what is the biggest technical challenge that you've encountered so far in the development of Cora?
Yeah, Jim, why don't you take that, and then I'll talk about it in the context of flight in the US, but go ahead.
Yeah, no, it's a great question. It's a hard problem, obviously, on a lot of different levels. Building an airplane's hard enough. Building an electric airplane's harder. Building an airplane that can take off and land vertically is harder still. On top of that, the autonomy aspects are also difficult. I think but that being said, I think we've been able to demonstrate solutions to all those problems. I think the challenge that we have now is really focused on aerospace integration. How do you operate a vehicle like this within the national airspace system and do it safely and reliably and robustly? And that's, but doing that, it's worth it. Being able to solve the pilot shortage problem, being able to have repeatable and safe systems, and it is in a scalable network that and safe is really important. So that's our big challenge right now.
Yeah, so let me add to that, because I think it's closely related. But if you think of the whole autonomous area, so right now we have partial autonomy. We have a pilot, in a ground control station. To get to full autonomy is a big deal, and it's everything from controls, avionics, to communications, to detect and avoid, to aerospace integration, and having all those things work seamlessly in a fully autonomous way. And so there's a tremendous amount of innovation that we are doing as it relates to autonomy. And so you could argue that part of it is almost as big as building the aircraft itself, because it's pulling together all these disparate pieces into a cohesive autonomous network.
Excuse me, I lost my audio there. After New Zealand, Gary, have you identified the next markets that you would like to be certified in and operating in? I mean, it seems self-evident that it would be the United States, but have you thought much beyond that?
Yeah, there is stuff we are going to do in between, if you will. Not ready to announce or talk about that yet, but our target is very squarely U.S. urban city. We call it our North Star. And so we have the North Star for the company. We know what our launch city is going to be. We're not announcing what the launch city is yet, but we know what it's going to be. We know where we're going to fly. And that's very squarely our target. There are some things we'll do in the interim after New Zealand and before we're certified to fly in the U.S. But again, not ready to announce some of those things right now.
But just to be clear, is your launch city, that's in the US, is it, or in New Zealand?
Well, let me clarify. The current aircraft, which is called Cora, will fly in New Zealand first. So that is absolutely our first step. When I talk about our North Star, that is our look at New Zealand as a test case. We're testing, working with a regulator, working with a community, working with an airline. And in New Zealand's case, actually working with the local native tribes to have social license and have everybody be supportive of what we're doing there. So that's kind of the preliminary step, if you will. When I refer to our North Star, that is the targeted city in the U.S., congested U.S. city, horrible traffic, where we will fly first. And then there's a whole city rollout. Beyond that, it's pretty aggressive city plan, but we have a team, focused around what we call our North Star, which is a challenging, area and congested area to fly in. But that's what I'm talking about. So that's the U.S. part of it, which will happen after New Zealand.
Okay, good. And a colleague is asking, can you just give us some idea of the sort of size of the test ranges that you're using, both in the US and New Zealand, and the sort of local restrictions that you're having to respect as part of that?
Yeah, so, the Hollister Airport, we've got a large hangar there. We've got, multiple aircraft that are down there in flight testing. I don't know how long the runway areas are, Jim. Do you know the total square footage of the Hollister Airport? I don't know.
Yeah, I don't know. It's a rural airport though, and so
Yeah.
it's the population density is pretty low. It's not actually a test range. It's a public use airport. So the FAA has a process that allows you to do experimental flight test the same way you would do with. So we have a letter of authorization from the FAA and a COA that allows us to operate at Hollister for these sorts of things. We have a similar arrangement with the New Zealand government for our test facility there. So it's not a test range, but we do have very specific controls on the vehicle and its systems. We also have a whole aircraft parachute. It's worth noting. And we have a very professional flight testing organization that makes sure that we're operating in a safe and responsible manner.
Yeah, the flight, to add to that, where we do flight tests in New Zealand is in a city called Tekapu. It's on the South Island of New Zealand. We share it with another operating company that mostly does tourist flights, take people around and look at the snow-capped mountains and that sort of thing. And so we have another hangar there and a full setup and ground radar and all that is established. And so we fly out of there, again, weather bearing every day, and then fly in Hollister as well. But they're both, GA airports.
Excuse me, I keep losing audio. This is a good question, I think. What metrics do you use to measure how competitive the economics are for the Cora aircraft? Do you have a sense of how much less they'll be than a helicopter, or compared with a general aviation fixed-wing aircraft, or even a car?
Yeah, so we've got very extensive models that have to do with, bill of materials cost for the aircraft itself, what the operation will cost to run. And so we peg it on dollars per mile. That's our metric that we are measuring to make sure that we are competitive, that people can afford it, that it's cheaper than a helicopter. And again, as I mentioned, we'll start with a more premium level and then drop down to the masses, if you will. But it's dollar per passenger mile is what we track.
Right, and you're pretty confident that it will be significantly cheaper than a helicopter, for example?
Yep, it will.
Good. Okay. You mentioned that during unpiloted flight, a ground operator can intervene if necessary. And maybe we covered a bit of this, but what sort of control does this operator have? Will it just be one dedicated operator per plane in the air at any one time?
Yeah, Jim, you touched on it briefly, but you want to expand?
Yeah, sure. So today it's one operator per plane, and the pilot has the ability to select alternate flight plans. The pilot has the ability to override heading, altitude, airspeed through like an autopilot-like interface. There's not like a stick and pedal sort of interface. You really don't want that because of latency issues, and you want the aircraft to behave well in the unlikely case that you lose link. And it's also sets a good foundation for follow-on efforts where the aircraft has more autonomy. But today, the aircraft flies itself. In response to most failures, the aircraft will execute the appropriate emergency action without pilot intervention. But as we go forward, we are working on incorporating things like automated collision avoidance, in-flight routing changes, all under the watchful eye of the operator. But it's those sorts of technologies that allow you to have many aircraft for a single operator. So it's a super interesting problem and been kind of foundational to making this into a good business.
Yeah, and just to add, even though we haven't announced it, that is in the ground control station is in partnership with a aviation. It's a certified ground control station that we're using. So we are partnering for that aspect of the solution.
Good point. Okay, well, we're going to switch from a sort of technical question, if you like, to a sociological question. Most people today won't even get into a standard contemporary aircraft if it isn't piloted, says the questioner.
Sure.
So what convinced you that people will fly in a pilotless eVTOL and that they're going to be ready to adopt this fairly quickly?
Yeah, I think it's like anything else, and I'll give you my own experience. So I have a Tesla. It has automated self-driving features, and when I first got it, I hadn't tried it, so I was driving the car. The car is a nice car, fun to drive. Now I can't live without it, and so gradually try it, and then try it again and see where the shortcomings are and try it again. And if you think about the problem, it's a harder problem to solve in a car than it is in the air. You have less issues and less variables to deal with. But having said that, yeah, sure, it'll start with people that aren't as afraid, if you will, of flying. And they will be in constant communication with the ground. So there'll be that comfort level, if you will, of being able to talk to the pilot on the ground, as they're in flight. So think of it like, they'll have a helicopter headset and in constant communication. But it'll be a progression. It's not going to be everybody. I'm sure each of you are writing about this, but if you, either talk to your spouse or a friend and say, would you get in one? They might be like, whoa, I'm not so sure about that. And so it'll be a progression over time, but there's enough people, again, if you think of the premium passenger, people that fly a lot, people that urgently have to get from point A to point B, we think that's going to be a market that people will grab onto quicker before it drops down to, everyday flight for everybody.
Good, okay. And can the Cora glide in the event of a failure?
Yep. Jim, you want to take that?
Sure. Yeah, so we do have a gliding capability. Yeah, absolutely. We can fly like an airplane. Right now, we don't have a conventional landing capability, but that's something that we're looking into supporting in the future for future aircraft. But that's an open question for us.
Sure. And somebody had a follow-up question on Agility Prime. I hear what you say, Gary, about Boeing's connection with the defense world. But just to clarify, are you, Wisk, actively bidding for Agility Prime yourselves, or would that all be channeled through Boeing?
No, yeah, no, we are not. We're
Right.
not, as Whisk, we are not directly bidding.
Right.
So
Okay.
our mission is to be pure commercial, and we're going to keep it that way.
Sure. Okay. And again, some of this we may have covered when we were talking about the ground station, but I want everybody to be as informed as they want to be. So a colleague is asking, is the ground station that you currently have in mind to use combined with aircraft telemetry for performance, structural loads, handling qualities, for the safety of flight and data analysis?
Jim, go ahead.
Yeah, absolutely. So today we do real-time, lots of real-time telemetry that does look at all those things, and for both safety of test and also to make sure that the test is effective and that we're learning the things we need to learn. We're obviously, being a Silicon Valley company, we love data. So after every flight, we get lots and lots of plots, which compare the vehicle's behavior to the model, which we're always trying to figure out, is it behaving as we expect? And usually the answer is it is behaving as we expect, which is awesome. So it's a really amazing test environment, and every day we definitely learn something new. We're doing a lot of time on the vehicles, which is also great.
Yeah. Okay, good. And somebody has a follow-up question, Gary, about when you reach the operational stage. You mentioned the operating company Whisk in New Zealand. Will they essentially have their own Part 135 certificate, or could these aircraft be operated by other organizations such as an existing airline? And then what about operations in the US? Would that be Whisk directly or somebody else?
Yeah, that's a great question. Yeah, it's a 135 equivalent for New Zealand, and it will be our New Zealand entity that's flying that. So we think it's important in this market. It's a brand new market, brand new technology, and there are no customers yet, right? Let's be honest. And so this is a very nascent market. We are going to be the OEM and the operator for the foreseeable future, and that will include the US. We think the experience, the learnings, as we engage paying customers, they're flying on our service. We, in essence, want to be in control of those two aspects of it. The rest of it, as I mentioned, will be a lot of partnering. DAA, Aerospace integration, ground infrastructure, communications, things like that will all be partnering opportunities. But we are going to be the OEM and the operator in both New Zealand and the US.
Just by way of follow-up on that, a question that's in my mind a lot is that many of the eVTOL pioneers seem to want to retain control of the operations, and I spend a lot of my time writing about private jet charter operators, helicopter charter operators, and to me those people are sort of an obvious customer base for aircraft like this, yet there seems to be practically no engagement between the existing business and private aviation sector and the brave new world of eVTOLs. I mean, is that an oversight? Is it deliberate? Why, to put it bluntly, why should you guys be the operators?
Yeah, it's deliberate, and I'll tell you why. Again, back to the early part of it, and this is a brand new experience and brand new technology and all of that. And so I don't see this going forever. Initially, we'll be the operator. You could certainly imagine in time we're just the OEM. But to start and control of the experience, if you will, and making sure people have a good experience. And so I'll give you a worst case scenario. Let's say we're just an OEM of this brand new thing and we flip it over to an operator. Well, if something goes wrong, this, the other thing, it has an effect on not just us, but the whole industry. And so, we want to make sure that we're providing in the early days the best experience that we can to the customers. And so that's why we're doing both. But again, as we start to roll out city after city after city, you can certainly imagine as it gets more mature, as people get more comfortable with it, that we'll partner with operators.
Well, just to be devil's advocate, why would you be the best people to start operations compared with people who've been in the operating business for, half a century? Is it due to the particular nature of the technology you're introducing?
It is, self-flying, all electric. It's all new kinds of things, and we have been operating for years, if you will. So the crew that is in New Zealand right now has been, it's a flight test operation, but that crew is transitioning to the operational crew. So it's not like a brand new experience for us. We've been doing it. In fact, we do it on a daily basis, and we run it as a full operation. And so, if we have the opportunity when things open up again, and any of you can come down and visit us in our Hollister facility, you'll see the command center, control center, our flight control center. And this is a proper operation that we are doing. We're not trying to say we're better than someone that's been doing it for 50 years, but for this particular technology, because it's new, and obviously we know the aircraft better than anybody, we think we can, create an experience that's the best for our customers as we start this thing. Again, it kind of dovetails with the question about how comfortable are people going to be to get into a self-flying vehicle, and we want to make sure that whole experience is great. They're talking to our ground operators, just that people are comfortable and feel safe flying in our vehicle.
Sure. And presumably, as you reach that stage, you'll be looking to recruit people who have more direct experience of, customer service, customer interaction. I mean, with greatest respect, you've got, a world-beating group of engineers there, but that's a different thing from providing an actual customer experience.
Yep. And, it might be subtle, but as mentioned, because we're doing New Zealand and because that's going to happen fairly soon, we're going to get that experience, like real live operator experience. And we're going to get that experience before, some of our other colleagues in the eVTOL space will get by going straight to the US, because it will just obviously take longer to get FAA certified. So we think that's, a big asset for us, that we are going to get that direct experience, and we can fine tune, what we're going to do in the US.
Mm-hmm. Good. Okay. Just switching back to certification, somebody is asking here, do you have views on the European certification environment as provided by EASA's special condition rules? Do you plan to engage with the European authorities? And Jim mentioned a parachute. Somebody's saying, well, that's not allowed under the special condition, but maybe that's not what you had in mind.
We are and do plan to engage, and I've focused a lot on the U.S., but part of our expansion plan is obviously European cities as well. Jim, do you want to comment on EASA and the special condition?
Yeah, I think at first glance, the special condition is very different than Part 23, but once you start digging into the details, they're actually pretty well aligned and similar. One of the obvious areas of interest is the safety targets, which are still ongoing. That might be a little different, but definitely one of the great things about having a partner like Boeing is that they have on the regulatory and policy fronts an amazing ability to keep track of not just U.S. certification efforts, but international ones. And so we're definitely interested in the EASA special condition. And looking at our compliance basis against both FAA and EASA requirements. With respect to the parachute, there are regulatory requirements, and there are also internal safety goals that we have. So even if it is not helpful from a regulatory basis, it's still of interest to us to make sure that we have as safe as possible aircraft.
Sure. And you've got somebody so engaged here, Gary, they're getting ahead of themselves, and they're saying, are you already working on a next version of Cora, a larger version of Cora? And somebody else is saying, could you see the aircraft potentially finding a role in carrying heavier cargo packages than the current generation of delivery drones seem capable of?
So yes, on all those questions.
Mm-hmm.
We are underway. It will be larger. more payload, things of that nature. So again, we haven't announced a lot of these details, but we're definitely underway. Yeah, and see other markets, again, like cargo and other things are interesting markets.
So Cora is sort of a family concept potentially that could be expanded in size and scope.
Yeah, it absolutely will be.
Yeah. Okay, good. Somebody's got a somewhat leading question here. They're saying, what are your impressions of other promising urban air mobility companies? In other words, your competitors. What is it that you think makes Whisk, a winning option, if you like? I mean, you must look at what's happening around you, and you said maybe only 4 or 5 will actually end up coming to market. So how do you assess the competition, and what sets you apart?
Yep. Again, I'll give you the answer, but again, I hope the people that are credible and have a real thing are quite successful. So Joby is obviously credible. Large funding round, which is the kind of capital that you actually need to go do this. They've been at it for a while. They have looks like a credible architecture. They look interesting. I would say that Volocopter, could be an interesting player. They're not quite funded well enough yet, but they have an interesting concept that could have legs. Lilium, we're not so sure, about that technical approach. That has to play out in terms of some of the things that they have advertised. To be honest, EHang kind of worries us. And so they're very aggressive. They're out early. Don't have a certified basis. And I guess back to the point, if people like Joby and Volocopter and some others are successful, it's good for the entire industry. On the flip side, if something happens, if there's an incident, that's bad for the industry. And so, one of the things we kind of worry about is whether EHang is a little aggressive at this point. And we certainly hope nothing happens and no incidents happen and that sort of thing. Let's see who else is interesting. Bell is just early, and they had their Nexus prototype and really haven't done much. Airbus hasn't done much. They had some projects and they canceled a lot of the projects. A lot of the people that were in urban air mobility have left and gone to other companies, including ours. Jim, am I forgetting anybody that might be Hyundai, brand new, could be credible. They've announced that they're going to spend a lot of money, $1.5 billion, ironically, the same number that we might use for R&D, but they don't have anything yet. And so I would say, in the market, people that have full-scale aircraft, have been flying, have been flight testing, what sets us apart, again, over 1,300 test flights without an incident. What sets us apart is the capital funding, with Larry Page and Kitty Hawk and Boeing. We've got the ability to make, progress through this, decade-long journey, if you will, with the right amount of capital. And then from a technology perspective, Jim and team have just created a phenomenal aircraft, and it's pretty exciting whenever you see a flight and it's all self-flying. It's pretty amazing when you see this 2,800-pound aircraft, fly by on an autonomous route. It's pretty amazing. So I think there's, right now there's just a small handful of people that are actually credible and have the amount of funding that it'll take to make this journey.
And you mentioned funding there. I mean, here we are in the the COVID age and sort of mayhem going on the financial markets and so on. Yep. Does that make you all the more glad that you got your financial ducks in a row last year, and you're not one of these people who's sort of scrambling around now trying to get the venture capitalists out of bed to talk to?
Yes, exactly. I would not want to have to raise money this year, next year, and maybe even part of the year after. It's it's tough, and again, it's we're talking you could call it unicorn or whatever, but it's $1 billion plus in terms of funding, And it's definitely not a venture capital type play because they don't have the appetite for that kind of funding and then how long it'll take to get a return. So it really is. I mean, we think we're fortunate. The other thing I did mention is, the partnership with Boeing. So, having an aerospace partner that's been there, done that is really important. And they've been tremendously helpful to us, across the board. So I think those are the things that set us apart. But, having said that, there's some other credible guys in the space, and, I wish them all the success, really, because I think it helps the market and helps the whole perception of urban air mobility.
Mm-hmm. And I think you may have answered this question indirectly. Somebody's asking, would you consider joining an ecosystem like the Uber Elevate business model or something similar?
Yeah, don't know on that one. So we'll see.
Keep your options open.
Yeah, I mean, they are the type of player that we would partner with, meaning somebody that can handle the multimodal, they have the app, they'll handle all the logistics and all that. So it's that type of partner that we'll partner with, but there are others that are credible people, airlines themselves, that want to get into this space, and they already have customers and they already have the infrastructure and all that. There are auto manufacturers that want to get in the space, that obviously want to tie the auto part to the aircraft part, as you talk about a multimodal experience. And so there's plenty of people to pick from. I would say we're not interested in just a press release saying we're doing something. We want to really, who we partner with, and we're keeping our cards close to the vest, if you will, on this, but who we partner with for that end customer engagement is, we're still working through that.
That's fine. You don't have to issue a press release. You can just share it privately with the 40 or 50 of us here, and we'll all have a scoop.
Sure.
Good stuff. Good stuff. Somebody's following up on operations. They're saying, can you just give us a bit more picture of how you see operations starting? Would it be, completely on-demand charter or some sort of scheduled point-to-point service? Just paint a picture for us.
Yeah, it will start scheduled. And I'll just talk about New Zealand. The flights there will be scheduled flights for customers. It'll be more of a curated experience. You could think about, don't know who's been to New Zealand, but South Island is just gorgeous. And, you have a lot of tourists, adventure kind of people that are going gliders, backpacking, that sort of thing. And so, we're going to create an experience and tie, things together, and that flight is going to be part of it. But we'll start as scheduled before we go to on demand.
Good. Okay. This might be one for Jim. Somebody's asking, will you integrate a HUMS system into the initially certified aircraft?
I would love to answer, but I'm not sure what a HUM system is. I have to admit.
A health and usage monitoring system. So it's very commonly used on helicopters. So it monitors for vibrations and things like that.
Yeah, no, absolutely. So the aircraft today has a health monitoring system where we look at lots of different parameters like temperatures and accelerometer data and so on and so forth, and voltages and currents, and we will continue to do that and expand upon that. So I guess the short answer is yes, absolutely.
Right. Okay, good.
And I learned something new. Thank you.
Go ahead.
No, just learning something new. New acronym for me.
Yeah, I see what you mean. Yes, that caught me out several times. Somebody's just following up on this description of Cora as being self-flying, and they're saying, how close to autonomous is the aircraft? Does self-flying go beyond a standard autopilot? Does it use artificial intelligence in any way, or just fly a pre-programmed route?
Yeah, it's flying a pre-programmed route, and that all occurs autonomously. So our pilots in the ground station, think of them as observers, and if they need to intervene, they will, but they're really just watching the flight. But it is a flight plan that is pre-programmed.
Mm-hmm, mm-hmm, mm-hmm. Okay, good. And how many Coras do you currently have flying? How many are active at the moment?
We've got 7 full-scale aircraft.
Good. Okay, split between the US and New Zealand, I guess.
That's right.
Good. Okay. So I've got a question here about functions such as communications, detect and avoid, and onboard versus ground usage. How much bandwidth do you need as you're transferring data and video down to the ground for either autonomous or flight or for the monitoring pilots? And to what extent does the bandwidth requirement dictate your approach to that?
Yeah, Jim, go ahead.
Yeah, so we don't actually need a lot of bandwidth. I don't think we're ready to disclose like what frequency bands we're using or the radios we're using or specific bandwidth numbers, but you know, I can say that the one benefit of having an autonomous aircraft that can fly a flight plan, you know, by itself and can respond to emergencies by itself is that the data link requirements are somewhat minimized that way. And you know, as we look towards the future, we're making sure that we can comply with all the spectrum requirements, but that's not an area where we think we need the huge technological leaps. It's more in other areas. So very limited bandwidth.
Right.
Yeah.
So without putting words in your mouth, it's not sort of a limiting factor by the sound of it at the moment.
No, absolutely not.
No. Hey, Jim, do you want to talk about the different comms channels?
Yeah, sure. So we have so there's sort of the safety critical data link, the command and control link, which is the primary way where the remote operator affects the behavior of the aircraft. In addition to that, there's a separate link for passenger communications. So while you're flying in the aircraft, you can ask questions or get guided along your journey. And that's obviously not a safety critical link in the same way. So we have 2 different links, and then on top of that too, we also have other links that allow for activities like you know, opening and closing contactors while the airplane is on the ground. So there are different links for different behaviors.
Right. Now going back to the 7 Cora aircraft that you say you've got flying, one particularly eagle-eyed observer in our midst says that some Coras look like they have different forward fuselages. Why is that? Is that true? And it looks like they have some seats, or perhaps not. So are they different, or is this gentleman hallucinating?
The gentleman is not hallucinating. So yeah, they are slightly different, and each of these are, you know, as we learn, we're adapting and making it better, if you will. So, you know, Jim, I don't know if you want to add anything to that, but there are slight differences between the aircrafts. They're consistent in its higher level architecture, but there are certain things like, you know, how the boom looks and such that we've kind of adapted and streamlined, you know, as we go forward.
Fair enough.
Sounds good.
Yeah. Somebody's saying, have you, as you look towards operation, have you considered what sort of aircraft utilization rate you really need to, you know, turn a profit and keep the bank manager happy? I mean, some people are envisaging, you know, thousands of air taxis whizzing around big cities minute by minute. Have you thought about that?
Oh yeah, we have pretty extensive models that lay that out. I don't think we'll probably get into that here, but yeah, we do. We have, I mean, the variables that we're thinking about as it relates to the operation are quite extensive. I don't know, Jim, I don't know how many we have, but it seems like hundreds. But you think about everything to how many aircraft you need, utilization rates, charge time, you know, all the different things that go into, you know, how often you're going to be flying, how long the routes are, you know, all sorts of different things. So yeah, we have quite an extensive model. It actually runs out 15 years from now in terms of, you know, what our operation is going to look like and some of the things that we need to consider.
Good point. We've got another technical question here. What kind of sensors do you use in the Cora? For example, camera, LiDAR, milliwave radar, ultrasonic sensors. What sort of sensors have you got?
Yeah, I don't think we're probably ready to share our sensor list right now, but I guess what I will say is that we are, we're designing with more or less standard aviation, aerospace system safety practices and aerospace equipment, meaning that all of our equipment has to have a high level of reliability and redundancy. And so even for our early operations, that's the case. But it's definitely an ongoing area of development when it comes to autonomy is sensors and something that, as Gary said earlier, we're working with some partners to help develop those systems.
Good.
Yeah, and you can, I mean, just to add to that, you can certainly envision sensors in the aircraft and sensors on the ground, and the combination of the two form what we need.
Yeah,
Right.
no, absolutely.
Right. Another eagle-eyed observer who's obviously been looking at your videos says, why are the vertical lift props, the propellers, angled slightly inboard or outboard? Or is that an optical illusion?
It's not an optical illusion. So Jim, why don't you do that one? Somebody's very observant here. They're doing a nice job.
No, I'm impressed. If they're looking for a job, let me know. But no, we call those cants. So the fans are canted both in roll and pitch, and the reason why is to augment yaw authority actually. So by rolling the fans, you can enhance the amount of yawing torque, vehicle yawing torque that you get from, say, spooling up the opposing corners like you would in a quadcopter. And that extra yaw authority helps us handle failure conditions like rotor out. So that's why they're canted the way they are.
Fair enough. Somebody's following up on what it takes to make a market here. And given what we were saying about utilization rates, they're saying, really, can you be sure that a 2-seat aircraft is going to have enough payload, enough yield, if you like? Is that just a sort of, in the first instance, that's what you can bring to market, but you'll need more capacity to make a serious go of this?
Yeah, no, we're see, how can I answer this? 2 is a sweet spot, as we've talked about. We think that in the early days, but this will be a family of options, if you will. And so we're not opposed at all to larger things, larger aircraft, more seats and all that. But 2 is certainly a part where we can start, and we think it's a sweet spot in terms of demand. If you look at a lot of the market studies, some people would say 1.6 riders, some might say 2.1, but it's kind of in that area of a 2-seat vehicle. And yeah, and we do, it's not an incredible amount of flights before we get to profitability. We think we can do that pretty quickly after launch.
Very good. Well, we're fast running out of time, and I have to confess it's almost my bedtime here in England, but we've got some great questions. I'll take a couple more before we wrap up and let you off the hook. Question here, is your alternative control channel encrypted so that it can't be spoofed and some bad guy take over control of the aircraft? That's a reasonable question.
Yep, Jim?
Yeah, probably not going to talk about the details of our cybersecurity plan. I will say that we do consider threats like that when we're laying out our operations and various attacks that the aircraft system might see. So it's definitely one of the issues that's top of mind for us for our near-term operations and longer-term operations. But so yes, we are worried about that, and yes, we do have mitigations.
Fair enough. And then final question, once you reach the production stage, where do you plan to build the aircraft, and what sort of work are you doing in terms of assessing how your supply chain will be sufficiently robust to turn out the sort of numbers that I know you'll be hoping to achieve?
Yep, so a couple of things. Right now, we're doing manufacturing in Palo Alto, not the lowest rent district in the world for manufacturing. So production will not be there. It's safe to say that we're not going to scale our manufacturing operations in Palo Alto. This is where, again, the partnership with Boeing helps, from a supply chain perspective and also from a manufacturing perspective. So not prepared to announce where we're doing scale manufacturing, but we do have the leverage of a lot of different Boeing facilities and expertise. So I'll just leave it at that.
Absolutely, and not so far away. Good. Well, Jim, back in mission control there, I think that's about it for the questions. I tried to amalgamate some of them. And Gary and Jim, I really thank you. I think you've worked overtime here. You've dealt with some curveballs, and I think you can gauge from that the high level of interest that people have in what you're trying to achieve.
Yeah, Charles, thank you for moderating this. Jim, thank you for setting this up. And for everybody that was on the call, the questions were great. This is the fun part, is doing the Q&A and having it be interactive. The upfront part is just to kind of set the stage. And so I really enjoyed the interaction. I thought this was a great dialogue.
We did too, thank you. And several people here are saying they're willing to sign up to be test passengers when you need that.
Awesome.
We're up for anything. Very high risk environment, aviation journalism.
Yes.
Good. Any closing words from you, Jim, there in mission control?
So yes, thank you, Charles. Outstanding session. Great job, Jim and Gary. Even with a little pause in the middle, I hope you get your gardening taken care of. So that was outstanding. Thank you so much for spending the full 90 minutes with us. I do notice that there are a few questions in there. If we collect those questions and send them off to you, would you be willing to fill in the details on some of those answers, and we can get those posted along with the video of this interview? Outstanding. Yep. That'd be great. I know a lot of our viewers have a great interest in what's going on. So with that, I say thank you so much for joining us today. This is about the 5th or 6th of our interview series, and we have another one coming up on July 7th with Bob Hammett of OneSky. So I look forward to having everybody come in and join us for that. And there's some additional virtual programming that we have at VFS that's coming along over the next 6 months as we kind of transition our content development into a virtual mode. Our next paid session, at least as it's scheduled right now, actually includes Gary. It's a session called Progress Toward Autonomous Vertical Flight. That'll be on August 11th, and registration for that will be opening up soon. So from myself and from VFS, we thank you for your support, and we look forward to talking with you all again further down the line. So have a great weekend, and thank you very much again.
All right. Thanks, everyone.
Great stuff. Okay. Take care, everybody.
Okay. All right. Bye-bye now.
Bye, everyone.